inverse of matrix 3 by 3, we can use the adjoint method. What we need to do is to divide 1 with the determinant and then times it with adjoint of matrix A. So firstly, we have to find the minor and then the cofactor. Next one is the determinant and the last one is the adjoint of the matrix. The first thing that we're going to look at today is the minor. As you can see in the screen, the matrix of A is 1, 1, 1, 0, 2, 0, 2, negative 2, and 3. And since the matrix is A, so the elements of matrix A is A, 1, 1, which is referred to row 1, column 1, continuing with A, 1, 2, A, 1, 3, and so on. So to find the minor at A11 element, we must consider that we are not looking at the elements at row 1 and column 1, which are highlighted in pink, but we are now just focusing on the elements that are highlighted in blue. Using the same concept, AD minus BC, we are now doing 2 times 3, which is A times D, and also minus B times C, which is minus 0 times negative 2. And the answer that we will get is 6. Now, with the same method, we are going to find the minor for A12 element, which we are now closing our eyes by not looking at the elements at row 1 and column 2. Just focus on the elements that are highlighted in blue, and with the same method, AD minus BC, 0 times 3 minus 0 times 2, and we would get 0 as the answer. If you are done, you can check the answers on the screen. Now let's look at the cofactors. As you can see, the cofactor starts with positive value of minor at row 1, column 1, continuing with negative and positive, and it goes alternately like that. And as for cofactor matrix A, we can just substitute the values of minor that we have got in finding the minor before for matrix A. So we would get the answer as shown on the screen. Now let's move on to how to find the determinant. So first, to find the determinant, choose any rows or any columns. So here I choose column 1 because I see 0 value in there, and that would make us easier to find the determinant. So make sure what you do is you times the value, the element, with its minor. So if I choose column number 1, so I need to time the first one is the element at A11 with its minor M11, and then minus A21 times M21, and last one plus A31 M31. Now, why do I have to put negative sign and positive sign over there? So keep in mind that we are now using the expansion of cofactors where there is positive and negative value. So take the positive and negative value at each cofactor for each element. So now you just have to substitute the elements with its value, and we would get 2 as the answer. The last step to find the inverse is to find the adjoint, which is simple. You just have to transpose each element in the cofactors. And lastly, you can see the answer on the screen. So now we can find the inverse of matrix A. What we need to do is just to divide 1 with the determinant that we have gotten, which is 2, and times it with adjoint A. We can take some time for you to find the answer. You can now check your answers with the answers shown on the screen.
Now, let's see an example. So, as usual, you just have to find the determinant first, but this time, it is better to use any column or row that contain 1 or more zeros. We will choose the first column and then we will get the determinant, which is 14. Next, you have to find the cofactor, and you have to make sure your answer is the same as written here. And now for adjoint, you just have to transpose the cofactor and then you will get the answer. And then to find the inverse, you just have to use the formula that we have learned before, which is inverse of matrices B is equal to 1 over the determinant of matrices B times with adjoint of matrices B. And then you will get the answer.